a save. He'll have the imprint of a puck in his palm after that one.
So to start off here, let's calculate the momentum of the puck. So the mass of the average hockey puck is 0.163 kilograms. According to the Disney fandom Mighty Ducks wiki, Reed's shot clocks in at 100 miles an hour. For context, the average NHL slap shot is around 100 miles an hour. But since this is an international tournament with the best of the best, it's not ridiculous to say that Fulton Reed, who only practices slap shots and he's one of the best in the nation at slap shots, could shoot at a pro caliber level. So, with the puck traveling at 100 miles per hour or 44.7 meters per second, its momentum would be 7.286 kilograms times meters per second. So the puck is brought to rest by the goalie, meaning that all this momentum is transferred into the goalie's glove, right? So the force that is exerted by the puck on the goalie's glove, the same amount is exerted by the glove on the puck. Using F is equal to ma, we can substitute A for change in V over T. Since the puck is being brought to rest, it's going from 44.7 meters per second to 0 meters per second. We can plug in 44.7 meters per second for that value. From some analysis of the scene, I was able to determine that the impact lasted 0.467 seconds because the impact lasts 14 frames from when it first hits the goalie's glove to when the glove comes to rest, and the video is 30 frames per second. So, using this formula, F is equal to M times change in V over T, we know the impact force of the puck on the goalie's glove is 3.4 newtons. The goalie's glove is a Vaughn glove. It bears resemblance to the gloves from the Velocity series. This movie was released in 1994, so we're using the measurements of the oldest glove from that series, the V1. We're going to be using the junior measurements because according to the Mighty Ducks subreddit, the characters are supposed to be 14 in this movie. So there's no data available online for the area of this glove, but there is data available online for the perimeter. So the perimeter of this glove is 39 inches per the Vaughn website. When the glove is flexed to catch the puck, it takes on an oval-like shape, approximating that the flexed glove is similar to a circular object with a circumference of 39 inches. Using circumference is equal to 2 pi r and a is equal to pi r squared, we can determine that the area of the glove, when it's flexed, would be somewhere in the ballpark of 121 square inches. For those unfamiliar with hockey gear and how it works, the goalie's glove is not meant to absorb the force of the puck. It's simply meant to redistribute the pressure across the entire glove. A glove with greater area spreads out the pressure more across a goalie's hand, making bruising less likely to occur in a specific area. In order to definitively disprove the possibility of bruising, I wanted to use a smaller area. If we use a smaller value than the approximated value, I can definitively disprove the possibility of bruising, since we're using a larger pressure value than it would be in reality. For the sake of easy calculations, I decided to use 100 square inches as my hypothetical decreased area. This came out to be 0.065 meters squared. Using P is equal to F over A, I calculated the pressure on the glove to be 52.3 pascals. You may be wondering, how much pressure does it take to cause bruising? According to a study I found online from REUPLOAD, the tensile strength of skin is 27.2 megapascals. In simple terms, bruising occurs when the blood vessels underneath human skin are ruptured. Therefore, the pressure exerted on the skin doesn't need to be equal to the tensile strength, but it needs to be comparable in magnitude, enough to the point that it's going to break blood vessels under the skin. The pressure required to break human skin tissue is 23 million pascals, while the pressure of this puck traveling at 100 miles per hour is only 52.3 pascals. As a result, we can conclude that no bruising would occur from this Fulton Reed slap shot.